Hello everyone. Today I am going to start the chapter hydrogen here. My name is Saurabh Pant and we are going to deal this chapter, which is rarely trouble for most of the people in the junior senior inter level. Still a revision is necessary for whatever the chapter might be, and yes, it is important for NEET examination, no doubt. So let's start this. Hydrogen, very commonly known element it is. There are three isotopes: hydrogen, deuterium, tritium. Hydrogen has one proton, there is no neutron there. Deuterium has one proton obviously and one neutron as well, so the mass number is 2. Symbol D also you can use. Tritium is radioactive and it has 2 neutrons and 1 proton, so total mass number is 3. Symbol we can use T. One very interesting thing you will see here, H2 D2 bond length are same, that is 74 picometer, but the bond enthalpy of D2 is more than H2. That means D2 bond is stronger than H2 bond, but bond length is same. Now some people come in trouble automatically, sir, how is that possible, sir? Bond length decides the bond enthalpy. True, bond length decides bond enthalpy, but only bond length does not decide the bond enthalpy. There are various other factors also. So yes, it's possible, even though the bond length is same, bond enthalpy obviously can be different, because not only the length, but attraction depends upon obviously proton, neutron and other nuclear forces as well, which we don't have to read here. Going ahead, hydrogen has a configuration of 1s1. So he can take one electron, become 1s2. So what is so awesome about 1s2? 1s2 is helium configuration, which is a noble gas. So apparently, after getting one electron, he will become comparatively inert. Or he can release one electron and he can be completely free of any load from his life, because the only load in his life was electron. And he can release that electron and become H+ as well. So yes, he can behave like alkali metal, that is the first group element. Also, it can behave like 17th group element, that is halogen, by becoming H-. So bhaiya dekho yaar, oxide, halide, sulfide, it forms like alkali metal. For example, Li2O, LiF, LiCr, LiBr, Li2S. In the same way, you have H2O, HFSCl, HBr, H2S. So it's very common that hydrogen can form compounds like alkali metals. But the ionization enthalpy of hydrogen is closer to the halogen rather than the alkali metals. In fact, it is diatomic. Metals, lithium, sodium, potassium, rubidium, cesium, they exist in the solid state structures. Whereas hydrogen exists like a molecule, and that too diatomic, just like halogen, like F2Cl2 Br2. In the same way, we have H2 as well. So that's a similarity here. So ionization enthalpy is closer to. Single multiple choice question can come. Which of the following factor hydrogen differs from the alkali metal? And the answer would be ionization enthalpy. Now, many covalent compounds are there. Just like halogen, like hydrogen forms many covalent compounds just like halogen, but yes, the reactivity of halogen as non-metals are much more as compared to hydrogen, no doubt. So bhaiya, hydrogen has no place in first group or 17th group, because somewhat behaving like first group also, somewhat behaving like 17th group also. So bhaiya, somewhere at the top of the periodic table we have kept it separately. So no, that's a problem with the modern periodic table as well. Hydrogen has no definite place. Going ahead, how to prepare it? Firstly, deal the lab methods here. In lab method, zinc is amphoteric metal here. He can react with acid as well as base. In both cases, he releases hydrogen gas. Now, this is Na2ZnO2. Sometimes they ask this name also. So it is sodium zincate. Sodium zincate, in case they ask the name when zinc reacts with NaOH. Commercially, major preparation method commercially is electrolysis only. Differently written, like first one, electrolysis of acidulated water. Pure water, why should we not take? We can take pure water also, but pure water have H+ concentration, OH- concentration, only 10 to the power -7 molar at 25 degrees Celsius, which is very less here. 0.00000001, that much concentration in molarity is going to be almost negligible, so very less amount of hydrogen will be produced. So we add a little bit of acid there. Maybe dilute H2SO4, so that we can do the electrolysis of, or if you want more than 99.95% purity of hydrogen, you just do the electrolysis of warm aqueous barium hydroxide using nickel electrode. So it's a very important commercial method, because very highly pure hydrogen you get. It's a byproduct in the preparation method of NaOH. So in the NaOH preparation method, we take brine solution, we do the electrolysis of that. So very clearly in electrochemistry also you have read, hydrogen will be coming out at, one more important thing, where does the hydrogen come out? So understand, in the case of water, hydrogen is in +1. So if he becomes H2, that means hydrogen from +1 is going to 0. This is reduction. And if it is reduction, this will be happening at cathode. So all this 1, 2 and 3 happens at cathode here. Hydrogen comes out at cathode. Also, you can take hydrocarbon with steam, heat in the presence of nickel as a catalyst. You will get the hydrogen gas coming out. See what actually happens. Like methane with steam at 1270 Kelvin with catalyst nickel. So why do we need nickel as a catalyst? Simple here. Methane is a gas, water is a gas. If they want to react, like steam we are talking about, if they want to react, you need a surface where they can absorb, stick on the surface, and then they can talk to each other, then they can react here. Otherwise they'll be moving here and there, collisions will be less, reactions will be less. So as a catalyst, heterogeneous catalysis we call it in surface chemistry. So methane react with water, steam basically, what we get CO plus H2, it is known as water gas. Very common product and very good fuel also it is. Also known as syngas. So why syngas? Water gas we can understand because water was a reactant. Syngas because it is used to synthesize many organic compounds like methanol also. That you will learn in the alcohol phenol ether chapter as well, preparation of methanol. Going ahead, if you take coal instead of hydrocarbon, if you take coal, it is called coal gasification. It is called coal gasification as well. So here in the coal gasification method, coal is treated with steam again 1270 Kelvin, we get water gas. Further, you want to increase the production of hydrogen, take iron chromate. So bhaiya ferrous chromate I have taken, what will happen at 673 Kelvin, reaction goes forward. So what will this do? It's just a catalyst here. It just increases the speed of reaction. Reaction goes further forward. CO reacts further with atmospheric oxygen as well to form CO2. And the reaction goes further and more hydrogen comes out there. So it's a very clear-cut method of producing more hydrogen. So it is called water gas shift reaction. The water gas shifted forward to produce more hydrogen. Now to purify it, we have to remove CO2 from here. So CO2 is removed by scrubbing. By scrubbing the CO2 using sodium arsenite. Sodium arsenite here is Na3ASO3. Now, out of these methods, industrial hydrogen, this commercial hydrogen, 77% produced by petrochemicals, 18% by coal, 4% by electrolysis and 1% by other method. So, very clear-cut MCQ can come from here ki bhaiya maximum industrial hydrogen is produced by, answer will be petrochemical. One very interesting thing is there that HH single bond, H is very small. The smallest atom that you know is hydrogen atom. So, bhaiya, HH single bond is the strongest single bond because it is so close, it's very tough to break. Very basic common sense here. Larger bonds will be easy to break. It's just like larger stick versus a smaller stick. So obviously here smaller stick will be tough to break here. Same logic, ki HH bond is the strongest single bond by atoms of any element. Of an element, you take any atom of element and when you combine them making a single bond, the strongest one will be of HH. So obviously, if the bond is strong, it is tough to break at the room temperature. So H2 is relatively inert at room temperature. So let's see some reactions of hydrogen. Even though it is inert at room temperature, relatively, obviously it can do some reaction at elevated temperatures. So let us start. So now let us see some reactions of hydrogen. So hydrogen reacts with halogen to form HX. It is obviously acid, HF, HCl, HBr, HI. Now reactivity of halogen go in this order always here. Fluorine more than chlorine, more than bromine, more than iodine. So here fluorine reacts even in dark. Fluorine is crack. He reacts with just everyone and uncontrolled reaction of fluorine is there. But yes, iodine being least reactive require a catalyst for this reaction to go forward. Moreover, H2 reaction with O2 forming water is highly exothermic, but it is so slow at room temperature. So why slow at room temperature? Because hydrogen is the strongest single bond by any atom of any element. O2 is a double bond which is sufficiently strong. So bhaiya, breaking them requires a lot of energy. So in the presence of electricity it happens very quickly, but at the room temperature the process is very slow, even though this process is highly spontaneous. But it is slow, so it does not appear like it is happening around us. Yes, delta H is negative, it is exothermic, thermodynamically feasible, kinetically very slow. N2 plus H2 giving ammonia. This also very clear cut spontaneous reaction, but again this reaction will also happen at a higher temperature, and hence this process is the Haber process that you are going to learn in the nitrogen family also. Maybe already you have learned. Going forward, will they react with metal? Yes, with metal they form hydrides. One example I am taking LiH, NaH, KH, RBH, CSH. Stability, when you go from lithium to cesium hydride, the stability decreases. Why? H minus is a small anion. very small, means not very, very small also, but small anion, and he loves to bond with small cation. तो भैया स्मॉल कैटायन स्मॉल एनायन मंची बॉन्ड, लार्ज कैटायन स्मॉल एनायन चड्डा बॉन्ड. तो भैया क्लियर कट LiH is going to be more stable. We can say more specifically talking about his high lattice enthalpy, but it does not matter. You can just remember this trend कि भैया small anion loves to bond with the small cation, and small anion does not like bonding much with the larger cation. So that's how the trend goes like. Going ahead, hydrogen can displace less reactive metal, less reactive than hydrogen, less reactive metal than hydrogen, he can displace from their aqueous solution, he can displace from their salt. So who are the less reactive metal than hydrogen? They are copper happa. In electrochemistry you have read, sir, what is happa? Again I am telling you, many videos I have told this thing, Hg, Ag, Pt, Pd, Au. So bhaiya copper happa. So one question is there in the NCERT salt example, ki if I take copper 2 plus salt like copper sulfate and I add hydrogen there, what would happen? So bhai sahab, copper sulfate will become copper by reduction. This process we use for extraction of copper from low grade copper also in metallurgy. Going ahead, vegetable oil, very common from class 8 onwards you are reading this thing. Vegetable oil with hydrogen, nickel as a catalyst give you margarine and vanaspati ghee. Going ahead, hydrogen plus CO. This is nothing but water gas. Hydrogen plus CO react with olefins. Olefins means alkenes here. So what will happen? They will make the aldehyde. If you have excess of hydrogen, obviously aldehyde get reduced to alcohol. So this reaction is called hydroformylation. Make sure this reaction is very important. Remember it clearly. Write it 4 times. You'll be able to remember it. The remaining reactions are very obvious. You don't have to mark them separately. Next. Read the uses of hydrogen from the NCERT. Very important uses are there here. In fact, it is used for welding purposes also. So the atomic hydrogen is allowed to combine over a metal surface. So it will release a lot of energy because atomic hydrogen or atomic nascent any atom is highly reactive. So it will try to combine to form hydrogen and releasing a lot of energy. Because obviously the HS single bond is the strongest single bond by any atom of any element. That is why we can understand कि भैया when HH will combine, a lot of energy will release and that energy will melt the metal and hence is used for welding. Such kind of many uses are given in 9.4.3 topic in NCERT. Make sure that you read them. Talking about the hydrides now, this kind of metallic hydrides and other types of hydride we are going to discuss. They are called not metallic precisely, they are called S-block hydrides. These are called ionic or saline hydrides. Now, sir, all the ionic hydrides are ionic in nature? Nahi yaar. By definition, all the S-block hydrides are called ionic hydrides, but some of them are covalent. So, who are those? Lithium hydride is covalent. Beryllium and magnesium hydrides are covalent. Also, beryllium magnesium hydrides are polymeric in nature. In fact, you will be surprised to know maybe that they have in them banana bond as well. So, banana bond was there in B2H6, na? Huh, B2H6 also have electron deficient bonding or banana bonding, but these polymeric BeH2 and MgH2 also have banana bonding and electron deficient bonding, 3 center 2 electron bonding, just like B2H6. Going ahead, these ionic hydrides are crystalline, non-volatile. They are not evaporated easily, they have higher melting points and non-conducting in the solid state. In the molten state, they will give ions like Na plus and H minus and they will conduct electricity just like you have read in the electrochemistry. So when you take NaH and do the electrolysis of it, at anode hydrogen gets released. This proves that hydrogen must be at minus oxidation state here and bhaiya from minus to 0 is increase in oxidation state. And minus to 0 increase means oxidation. And at anode it is coming out. So this proves that 100% hydrogen was in minus oxidation state. That is why it is coming out at anode. After oxidation it is coming out. Because hydrogen has only 2 options. Either he can exist like H plus or H minus. H plus to H2, reduction. H minus to H2, oxidation. So some people get confused. Sir, there to previously you were saying hydrogen comes at cathode. Now you are saying at anode. Bhai sahab, if hydrogen plus get reduced to hydrogen, then it will come at cathode. Na? If it is coming at anode, it proves hydrogen is not in +1, hydrogen is in -1. Going ahead, these hydrides, the ionic hydride, they react violently, explosively with water, forming, for example, NaH forms NaOH and hydrogen. So hydrogen gas goes out. Now, one more example, LiH is there. LiH is less reactive. It does not react so vigorously, just like NaH was reacting, but he reacts with Al2Cl6 and B2H6 to form reducing agents like LiAlH4, very famous in organic chemistry, and LiBH4. One task I am giving you, if you are seeing this video, search in S block also, in boron family also, this reaction, this kind of reaction you will find there, same reaction in boron family also, search in the NCERT. Going ahead, second class is covalent or molecular hydrides. So non-metals, majorly P block elements, they form covalent or molecular hydrides, the name is there. Three types are there: electron deficient, where the octet is not completed. Example, diborane, B2H6. Electron precise, octet exactly completed and there is no lone pair left. That means like methane and silane, SiH4, CH4. Similarly, electron rich means octet got completed and lone pairs are also there. So that means expanded octet? Nahi. Octet completed, but after completing the octet also it has lone pair left. That means the octet is not violated, but after making the bonds, after completing the valency as well, some lone pairs are left. So if there is lone pair on the central atom, electron rich, no lone pair, but octet completed, electron precise, exactly required. Electron deficient means less than octet. Going ahead, then we have metallic or non-stoichiometric or interstitial hydrides, and it's clear by the name. Non-stoichiometric means there is no stoichiometric ratio in which they combine. For example, LiH combines in 1:1 ratio. Mg and hydrogen combine in 1:2 ratio, but YbH 2.55, YbH 1.87, these kind of any values are possible. Similarly, you can give many examples, but understand three groups are there where no hydride is possible from the D block, and those groups are 789. 789, that means 7th group, 8th group and 9th group. Sir, which are the element in the 7, 8, 9 group? I am not able to recall. Simple bhaiya, 7th group is manganese, this is iron, this is cobalt. So manganese hydride not possible, iron hydride not possible. Similarly, cobalt hydride not possible. So they can ask you this question: which of the following hydride is not possible? And bhaiya search for iron, search for manganese, search for cobalt hydrides. Those will be the answers. Going ahead, in the 6th group also, only CrH, chromium, forms hydride. So who are the other elements in the group? Molybdenum and tungsten. They do not form the metallic hydrides. Going ahead, these metallic hydrides, they have kind of the structure like metal only. Most of them, some of them, not most, but some of them. So they conduct electricity as well as heat like they are metals, like metals only. But the reactivity, the conductivity is lesser than the metal. That means chromium hydride is also a good conductor of electricity, is also a good conductor of heat, just like chromium, but obviously chromium will be better conductor as compared to chromium hydride. This was about the hydride topic. Let us now go to the water. Make sure that you revise this part properly and read the uses of hydrogen from the NCERT before going ahead to anything further. So let's carry on. So now talking about one of the solved example of NCERT, very nice, interesting question and very important for NEET exam. So the question is, pH 5 does not exist. Why? Because the pH bond does not release enough energy to excite phosphorus to +5. As simple as that. Now, when we are comparing D2O and H2O, firstly, reaction wise, they both react in the same way. I'll talk about that also. But understand, melting point, boiling point, enthalpy of formation, that means enthalpy of formation means, see, both of them H2O, D2O, their enthalpy of formation is negative. That means D2 plus O2 giving you 1 D2O and H2 plus O2 giving you 1 mole of H2O. For both the cases, the amount of energy released is there. That means endothermic, they are not, they are exothermic hydrides. That means when they are formed, the energy get released. So whenever they are formed, nahi. When they are formed from their native element, from their standard state, that means H2 plus O2 giving water, D2 plus O2 giving D2O, these reactions are exothermic. So both the enthalpy of formations are negative, but I am comparing the magnitude. Ki who release more energy? Then enthalpy of vaporization, viscosity, temperature of maximum density. For example, for water, it is 4 and for D2O, it is 11 degrees Celsius. That means at 4 degrees Celsius, you might have read that water has maximum density, that is 1 gram per ml. Below that, above that, the density varies. It goes below 1. Similarly, D2O has maximum density at 11 degrees Celsius. And density itself, For all these values, bhai sahab, D2O is more than H2O. So we have to mug up this much? Nahi, you have to just mug up only, be smart here. That's what we call smart work. Why to mug up all these things? Just remember that dielectric constant, water is more than D2O. Dielectric constant of water is more than D2O. Apart from that, any other property of D2O is more than water. As simple as that. So understand what is dielectric constant and what is the implication. So dielectric constant high means ionic compounds like NaCl, KCl, these are more soluble in water. So NaCl has more solubility in water as compared to D2O. Sir, what about covalent compounds? Covalent compounds are more soluble in the solvent whose dielectric constant is lesser. So if someone asks methane, for example, so methane is a gas, ignore that. Let's take some example like alcohol, where it will be more soluble. This kind of question if they ask you, hydrocarbon, large hydrocarbon, if they ask, for example, we can take decane, is more soluble in water or D2O. So it is less soluble in both of them, but comparatively more soluble in D2O because of lower dielectric strength or dielectric constant. So more dielectric constant, ionic compound more soluble. Going ahead, the crystalline form of water is known as ice. Obviously, you might be knowing it, just a very fancy way of saying it. Now, ice is hexagonal in the structure, but at a very low temperature, the hexagonal structure becomes cubic. So it's a very important fact. Hexagonal is a larger structure. So at a very low temperature, it comes closer and forms a cubic kind of a structure. Going ahead, density of water is more than ice. That's why you might have seen that ice floats over water. So it's very common thing, ice will float over water. It's not so common for solids to float. Think about any other solid that floats over the liquid air. So ice has one exceptional property because of very less density. Sir, why less density? Due to hydrogen bonding, it has a big cage-like structure. So because of that big cage-like structure, a lot of empty space is there in the middle, because of which the density is less. And lesser density things will float over higher density. So ice has lesser density than water. That's why ice floats over water. That's why these icebergs, you see a lot in the movies and videos also, that icebergs are floating over the ocean. Why? Because ice can float over water. Now in ice, oxygen atom, each oxygen atom is surrounded tetrahedrally by 4 other oxygen atoms as well. Firstly, understand, each oxygen atom is surrounded by hydrogen, and that hydrogen is connected to oxygen because hydrogen bonding is there. But if you compare oxygen to oxygen distance, that is 276 picometer, and around one oxygen you will get 4 other oxygens. Obviously a hydrogen also in the middle. Ignoring that, oxygen to oxygen, there are 4 near oxygen at tetrahedral structure. Talking about the reactions of water, water is amphiprotic and amphoteric. So are they different? More or less same. Amphiprotic means he can give H plus and take H plus. Amphoteric means he can react with both acid and base. Like water can react with ammonia to form NH4 plus and OH minus. Ammonia is a base. Water acted like an acid here. H2S with water forms H3O plus and HS minus. Here water acted like a base because H2S was acid. So water is like, it depends upon you here. You want to behave like an acid, he will behave like a base, or vice versa. Now water, this is called autoprotolysis, or we can also say this is auto-dissociation, self-ionization. What happens here? Water react with another water, give one H plus to the other water. What does it mean? Here this water is acting like an acid. He give the H plus to the other water, himself become conjugate base OH minus. The other water, which is H2O, took the H plus and became H3O plus, that is conjugate acid. So one question comes, how many conjugate acid base pairs are here in this reaction? So 2 reactive pairs are there. How many acid bases are there? So 2 bases and 2 acids are right now visible to us at this point of time. Going ahead, about redox reaction here. Sodium react with water. So bhaiya, hydrogen gas goes out because sodium is more reactive than hydrogen. He kicks away hydrogen, forming NaOH. In photosynthesis also, oxygen get converted into CO2 and water. So that is also a redox reaction. Fluorine is highly reactive, and he is one of the very rarely known substances which can actually oxidize water at room temperature. So fluorine oxidizes water to form HF and O2 gas goes out. Understand this question previously which I told you, acid base, conjugate acid base. I am telling you for this specific reaction in this way. If some big question they ask you in this reaction, how many conjugate acid base pair are there? In that case, you will have to find all the conjugate acid base pairs there. Right now, I am telling you this is the base, this is the conjugate acid, this is the acid, this is the conjugate base. Please don't over understand and misunderstand this thing. This is just directly the NCERT statement, and from there if the question comes, this is how the answer would look like. चलिए, going ahead, P4O10, SiCl4, water will react and these reactions are called hydrolysis. तो भैया this reaction, if you have P block, you have read many a times this reaction you might have seen. So like P4O10 is non-metal oxide go in water form oxy acid. Non-metal oxide, oxy acid. Sir, what if metal oxide goes? Then hydroxide. So if Na2O goes, NaOH formed. In water, if Na2O will go, Na2O will go, NaOH will be formed. No hydrogen gas released there. P4O10 goes, H3PO4 formed. Going ahead, SiCl4 with water, what will happen? Firstly, all the Cl will go, O2 minus can come. So, bhaiya, very easily chemically you can balance, electrically you can balance, ki 2 minus will come, so 2 Cl minus will go. So, for 4 Cl minus, 2 O will come there, so SiO2, SCl goes out. Sir, some people worry about, sir, balancing, sir, how many SCl? Yeah, it's very obvious here. 4 Cl are there, so 4 SCl will go. It's not a big deal. Going ahead, hydration, hydrated salt can be of many types. The water of hydration can be of many types. One example is coordinated. Here, it is forming a coordination compound with the chromium. So, it's a coordinated water hydration. BaCl2.2H2 is only one example in your course. Only one example in your course, which is interstitial hydrate. So, BaCl2.2H2O is interstitial hydrate example. Then, CuSO4.5H2O, very, very important question. 2 times came in the previous year NEET exam. Solved example of NCERT, very, very important. Ki copper sulfate.5H2O, how many are hydrated, how many are hydrogen bonded? Simple trick you can use. This trick is not always true, but it will work in case you don't know the answer. Plus 3 oxidation state generally have a coordination number 6. Generally, exceptions are there. For example, Mn2 plus can have 6 water around itself. But anyway, generally, plus 3 oxidation state coordination number 6 and plus 2 oxidation state coordination number 4. So, copper plus 2 out of 5H2O, 4 will become coordinated, 1 will remain out as hydrogen bonded. So, bhaiya, in copper sulfate.5H2O, how many water are hydrogen bonded? 1. And how many water are coordinated? 4 of them. Very important question. So, these are some reactions we have talked about. Let us carry on here to the hardness of water. So, let us talk about the hardness of water now. So, the chloride, sulfate and hydrogen carbonates of calcium and magnesium ion gives the hardness to water. Before going into what is hardness of water, we have to firstly understand who gives it. So, are the chloride, sulfate, hydrogen carbonates are the main villains here? Answer is no. The only thing that these people do is that they form soluble salts with calcium and magnesium ion. And these two people are the real villain. So, if you want to remove the hardness of water, you have to remove these two people from here. Sir, what kind of villain they are? Simple here. They form scum with soap. That means they do not form lather with soap. Understand here? With detergent, it can form lather. So, understand that's the simplest method of using the hard water without any scum. But with soap, it does not form lather. So, bhaiya, for example, this is the sodium stearate we have. It's a standard soap that we use, C17H35CuNa. It reacts with the calcium and magnesium ion of the water. What it was supposed to do, it was supposed to form micellization. It should be doing, forming some lather so that we can wash the hand, we can take bath. But the problem is, these people react with Ca2 plus Mg2 plus and will form a precipitate. And this precipitate is white color scum. Sir, any problem with the scum? Firstly, no lather. There is no lathering there. So, no washing possible, no cleaning possible. Secondly, it makes the hair dull. That's a big problem. Plus Na plus will go in the aqueous medium. That means it will go in the solution. That's as simple as that. In simple words, Na plus remained as it is, and bhaiya, the soap, the main part of the soap got precipitated as scum. So who are responsible? Ca2 plus Mg2 plus. So then why do we say chloride, sulfate and hydrogen carbonate? Because these bhai sahab, they with calcium and magnesium 2 plus, they allow Ca2 plus magnesium 2 plus to remain in the solution. So bhaiya dekho yaar, how to remove the hardness of water? So there are two kinds of hardness, we can say temporary and permanent. Temporary hardness is that hardness which is due to the hydrogen carbonate salt of calcium and magnesium. Why? You can simply heat it and the hardness will go. Why so? Because if you heat magnesium carbonate, bicarbonate, calcium bicarbonate, in fact any metal bicarbonate, it will release carbon dioxide and become carbonates. And calcium carbonate, magnesium carbonate, both are precipitate. In fact, magnesium hydroxide is a better precipitate. So magnesium carbonate is formed. reacts with water and form MgOH whole twice and precipitate, and calcium carbonate forms and precipitate as it is. So we can understand simply by boiling you can remove the temporary hardness. Second, very important method is Clark's method. Direct question ki what reagent is used in the Clark's method? Answer is calcium hydroxide. Very simple, very straightforward question. What happens here? Nothing. We treat the hard water which contains calcium and magnesium bicarbonate with calcium hydroxide. What happens there? CaCO3 will precipitate. CaCO3 again precipitate, but Mg here precipitate as MgOH whole twice. So bhaiya precipitation of Ca2 plus Mg2 plus happens. It leaves the water alone, and yes, now you can use the soap and the lather will be formed. Understand here, the caution here is that calcium hydroxide calculated amount should be used. Sir, why? What's the problem? Problem is that imagine this much of calcium bicarbonate was there and this much calcium hydroxide you added. So what will happen? Think here. This much calcium hydroxide reacted with the calcium carbonate, something got reacted, but a lot of calcium hydroxide left. Don't forget, Ca2 plus is the villain also. So if you add by mistake, add Ca2 plus in excess, what will happen? You will remove the temporary hardness and will give the permanent hardness here. So understand, for removing this temporary hardness by Clark's method, calcium hydroxide should be added little bit in a very calculated amount so that extra Ca2 plus is not left in the solution. What is permanent hardness? Hardness due to the salts which cannot be precipitated just by heating, like chlorides and sulfate of calcium and magnesium ion. How to remove them? Simplest method, use Na2CO3 here. Washing soda we can say, washing powder we can say. So what will happen? Nothing. Na2CO3 will convert them into carbonate or maybe hydroxide and will precipitate it. What will happen to chloride and sulfate? It will remain in the solution. They are not the problem. Main villains we precipitated. M2 plus can react with Calgon. It's called Calgon method. Here very nice strategic thing we are doing. What we are doing? We are letting calcium 2 plus magnesium 2 plus in Calgon method. Ca and magnesium will still be in the solution, but we are tying the hands. That means they will not be able to react with the soap. Is that possible? Yes. What we do? We take Calgon. Calgon react with Ca2 plus Mg2 plus to form this complex, and bhaiya this metal is crying here, this calcium magnesium is crying here because it is not available for the reaction with soap anymore. So even though it is in the solution, it is not in the free form, it is in the coordinated form, in the complex compound form now. So it's the Calgon method. Carrying on, NaZ zeolite, you have read in the case of carbon family zeolites, NaAlSiO4. It's called permutate or zeolite. It reacts with M2 plus. What happens? Nothing here. M2 plus from the hard water reacts with NaZ and will deposit as MZ2. And bhaiya Na plus is given in the solution. So the main villain got stuck. Sir, how does that happen? I am not able to imagine. Simple. Imagine my hand is zeolite. Pass hard water through it. Okay, na? On this I have a zeolite coating. Pass hard water. So Ca2 plus will react with the zeolite, will stay here, and the water will go and take the Na plus. Nice, awesome, no problem. Going ahead, what will happen after some time? My hand, all the Na plus will go from my hand and M2 plus will come. So my hand will have MZ2 solid deposited. That is called exhausted zeolite because now no Na plus is left to exchange with Ca2 plus and Mg2 plus. So to regenerate it, what we do? We treat this with aqueous NaCl. We treat this with aqueous NaCl. Na plus will come again. M2 plus will go. So bhaiya, we get again the regeneration of the permutate. Very important how the permutate or zeolites are regenerated after exhausted. How the exhausted zeolites are regenerated by treating with aqueous NaCl solution. Next is synthetic resin method. It is more efficient than zeolite method. Kind of mechanism is same. For example, I take RSO3H. Okay, it's an organic sulfonic acid. We react this thing with sodium salt or sodium basically, and we get RNA. So we convert this RSO3H to RNA. Then what we do? Nothing, just M2 plus is there. That will be exchanged from the hard water and you will get R2M solid deposited. Again, this is exhausted synthetic resin. Same way, my hand is the ion exchanger. Send water. Na plus will be sent in the aqueous medium. Ca2 plus will be deposited as R2M. And this R2M is exhausted, is completely exhausted synthetic resin. How to regenerate? Regenerate by adding aqueous NaCl. So both zeolite as well as synthetic resin are regenerated by adding aqueous NaCl. One more method is there in the synthetic resin method, and in that method we have to understand what we do. We take, firstly, what we get purely demineralized water. So what is demineralized water? Simple yaar. Demineralized water means the water without any soluble salt, without any salt. Demineralized water we have. So how do we get demineralized water? How do we remove all the minerals from the water? That is by the ion exchange mechanism that we follow here. So understand what we do. We take two ion exchangers. ठीक है भैया? Connected in the series like this. Two like tubes like this, है ना? Containers we can say. This is coated as well as this. Here also it is coated. This is also coated. By what they are coated here? From here I am going to send hard water containing obviously M2 plus, and this is the cation exchanger. Cation exchanger, what will it contain? It contains, for example, RH. What is RH? RH is the acid. This RSO3H, na? This is here. So on the walls, I have RH. What next? Next, what happens? Firstly, let's understand what happens here. Chalo, theek hai. We can discuss here also what is there. Here we have RNH3OH. This is also a solid, and this is also a solid. We are making the coating of it. So when the hard water goes here, M2 plus exchange with RH. M2 plus exchange with RH. So what reaction happens? Nothing. RH react with M2 plus aqueous to form R2M, and the H plus goes in the aqueous medium. So basically this exchanger exchanged H plus ion and took the M2 plus ion. So here what happened? You got the deposition of R2M, this solid, it got deposited here in the exchanger, and H plus went in the solution. So the question they ask, कि when the hard water crosses the cation exchanger, what medium the hard water will have? Because H plus is going in the water, तो भैया the water will be acidic. That's why we connect the anion exchanger also. So when we connect the anion exchanger, what will happen? The Cl minus or sulfate will go and react with the RNH3 plus. चमका भैया, RNH3OH. It react with the Cl minus there from the hard water, forming RNH3Cl solid depositing here. And what goes out? OH minus released out, and it makes the medium basic, and these together will make the water neutral when they go out. Very nice, awesome mechanism here. So what happened? It was RH. RH exchanged the M2 plus with H plus. So H plus came in the solution, went forward because it was acidic. To balance it, I passed through an ion exchanger. It exchanged the anions, giving the OH minus in the return, making the medium neutral again. So from here, neutral demineralized water goes out. Is it good for drinking? It's not bad, it's not good as well. Why? Some minerals our body need. That's why we need some mineralized water. But anyway, if you need distilled water, method is good. You can use this. So bhaiya, question arises, how can you regenerate the exhausted exchanger? Simple. What is left? Sir, R2M solid is left and RNH3Cl is left, remaining went in the aqueous medium. बहुत बढ़िया, no problem. What you want to regenerate? You want to convert R2M into RH again. है ना भाई? And you want to convert RNH3Cl into ROH again, RNH3OH again. So if you want to convert R2M into RH again, add dilute acid. You want to convert RNH3Cl into RNH3OH again, add dilute NaOH or dilute base. So when you add dilute base, RNH3Cl will be regenerated. So the anion exchanger exhausted is regenerated by adding dilute base. And bhaiya, acid or cation exchanger is regenerated by adding dilute acid. So this is your cation exchanger, anion exchanger, and this is how the process is carried out in the actual real life. Now I will go into the H2O2 part next. Don't worry, I will be talking about the numericals also of the water of hardness, but I will be compiling the numericals of H2O2 volume strength and degree of hardness numericals together at the end of this lecture. Let's go to H2O2 part now. Hydrogen peroxide, that is H2O2, a very famous compound and a very important compound for NEET exam. Firstly, see the structure in the firstly, it's an open book like structure. So let's for say example, I have a book like this. So this is open book like structure. So here we have one oxygen here, one hydrogen here, another hydrogen here. So this kind of open book like structure will be there. So understand, I hope little bit of imagination you can do here. This angle is called dihedral angle. The angle between the two pages of this open book is dihedral angle. In the gas phase, the dihedral angle is big, that is 111 degree, around 111.5. In the solid state, it comes closer because of compact packing. In the solid state, it becomes closer and the angle goes to 90 degree only, around 90.2. Then, because this angle is decreasing, dihedral angle, some angle has to increase. So, bhaiya, this angle, OOH angle, which was 94.8, increased to 101.9 degree. Values you don't have to remember, you have to just remember dihedral angle decreases. As a result, when gas becomes solid because of compact packing, as a result, some angle has to increase, that is OOH angle increases, as well as bond length also little bit increase. You can see 95, 98.8 picometer. Preparation method here. We take barium peroxide. Understand, it is not oxide, this is peroxide. So this is hydrated barium peroxide treated with H2SO4. BaSO4 is a solid precipitate with H2O2 plus water is produced there. That's how we get H2O2. Simple method. Peroxide makes peroxide. So peroxide get transferred from here to water and we get H2O2 here. Excess of water is removed by evaporation. Going ahead, this you have read in the electrochemistry also, that HSO4 minus, highly concentrated, 50% concentration of H2SO4 is required. On electrolysis, we get H2S2O8. This is known as peroxodisulfuric acid. Peroxodisulfuric acid, also known as Marshall angle, Marshall acid. ठीक है भैया, तो Marshall's acid on hydrolysis firstly will give H2SO5 and H2SO4. On further hydrolysis, final hydrolysis, H2SO4 will come out. Sir, how many? 2 of them will come out, and bhaiya H2O2 will come out as well. So we understand on further hydrolysis, what will happen? You get 2 H2SO4 and H2O2 comes out. These are the two preparation method. This little bit variation, like we take K2S2O8, that means potassium peroxodisulfuric acid or disulfate, sorry, with hydrolysis, but this time we are doing with the heavy water. So when we do with D2O, D2O react in the same way like H2O reacts. So here instead of getting, for example, KHSO4, instead of that I am getting KDSO4 and D2O2 is produced like you got it here also. Going ahead, industrial method, you take 2-ethyl anthraquinol, react with the air. So bhaiya oxidize, it will be oxidized from anthraquinol to anthraquinone. That is the oxidized product here. You don't have to know the name. H2O2 come out as byproduct. Further, on reduction, you get 2-ethyl anthraquinol back. Anyway, for preparation of H2O2, no need of reduction. Just oxidize 2-ethyl anthraquinol. So apart from the oxidation product, you will get H2O2 also. Now H2O2 is miscible in water at all proportion. It's highly soluble in water because of hydrogen bonding. In fact, H2O2 and water, they exist together as hydrate also. So what is that? They behave as a pure liquid. That means they melt at a specific temperature, that is 221 Kelvin. You can't tell it is water or H2O2. It becomes a totally new liquid, that is H2O2.H2O, and this hydrate has a specific melting point, 221 Kelvin. You can keep this in mind. Commercial sample of H2O2 is 10 volume. So what is volume strength? I'll explain in the next part of the video. But just remember this thing, that commercially H2O2 is sold as 10V, which is 3% of H2O2 by mass. Going ahead, about the reactions here. देखो H2O2 भाई साहब can go from -1 to -2. In -2 it has two options. It can become water in -2 or OH minus. But sir, in OH minus तो only -1 is there na. Charge on OH is -1, where oxygen is -2, hydrogen is +1. So net -1 is coming. So understand, oxidation state of oxygen in both cases -2. So here H2O2 can become water or OH minus. When H2O2 oxygen get reduced, the oxidation state of oxygen here is -1. On reduction, it becomes -2. So on reduction, if I am getting reduced, I am behaving as oxidizing agent. So when H2O2 behave as an oxidizing agent, the byproduct is H2O or OH minus. Sir, when H2O made in acidic medium, when OH minus is made, very basic question here, OH minus which medium? Basic medium. So in the acidic medium, H2O2 gives a byproduct of water. In basic medium, H2O2 give byproduct of OH minus. So acidic medium H2O, basic medium OH minus. In which case, when H2O2 behave as oxidizing agent. Sir, can he behave as reducing agent also? Yes, he's obviously a better oxidizing agent. He's a better oxidizing agent. Sir, why? Because it can release nascent oxygen. Any person releasing nascent oxygen is a very good oxidizing agent. But yes, it can behave as a reducing agent also. He can be oxidized from -1 to 0. -1 to 0 is increase in oxidation state, getting oxidized, behaving as a reducing agent. In acidic basic both medium, this is the byproduct. 90% questions will come for, you will get the answer by the byproduct only. So you don't have to mug up all reactions here, but for the safety purpose, remember all of them, especially these reactions, which I will tell you. But majorly remember this thing, that bhaiya byproducts are important here, and very conceptually you can remember them. Next, तो देखो यार, H2O2 behave as oxidizing agent in acidic basic both medium. Fe2 plus to 3 plus conversion H2O2 can do in both mediums here. PBS to PbSO4, NCERT says acidic medium, so remember that. What about Mn2 plus? Simple. Understand this thing, in basic medium, Mn plus 4 or MnO2 is more stable in basic medium. In acidic medium, Mn2 plus is more stable. This will help you in D and F block also, because MnO4 minus in slightly alkaline medium, byproduct is MnO2. But in acidic medium, the byproduct is Mn2 plus. Because in the basic medium, this bhai sab is more important, more stable. In the acidic medium, Mn2 plus becomes more stable. So, when you talk about Mn2 plus, getting oxidized by H2O2, what will he form in basic medium? Mn4 plus obviously. Will this reaction be possible in acidic medium? No. Why not? Because Mn2 plus already is stable in the acidic medium. Understood the trick, bhaiya? Next, MnO4 minus I've taken here, but H2O2 behaving as reducing agent. Why, sir? Because MnO4 minus is in the highest oxidation state. Okay, bhai sahab? If I am in the highest oxidation state, I cannot get further oxidized, na? So if you want to react with me, you can behave as oxidizing as well as reducing agent. I can behave only as oxidizing agent. So we have an agreement, na? I can behave only as oxidizing agent. So bhaiya, you have to behave as a reducing agent, otherwise no reaction is possible. In this case, MnO4 minus is the highest oxidation state person. His oxidation state is highest possible. He cannot be further oxidized. So all he can be is an oxidizing agent. He can just get reduced. Person in the highest oxidation state are always oxidizing agent, nothing else. To understand, he behaves as an oxidizing agent, so he will get reduced. In acidic medium, Mn2 plus formed. In basic medium, MnO2 formed, plus 4. As simple as that. Sir, byproduct, when H2O2 behave as reducing agent, the byproduct always, in this case, all case O2 is the byproduct. Sir, what about this reaction? In acidic medium, water is the byproduct. In basic medium, OH minus byproduct. In acidic medium, water is the byproduct. In basic medium, OH minus is the byproduct. Brilliant. Let's carry on. HOCl, Cl was plus 1, got reduced to Cl minus. Why, sir? Because HOCl is a better oxidizing agent than H2O2. He can also release nascent oxygen and he's better here. So what happens? Simple. HOCl get reduced to Cl minus. Sir, which medium? HOCl is acid here. So it will happen in acidic medium only, na? Sir, byproduct, bhaiya, in all the medium, when H2O2 behave as reducing agent, byproduct always O2. Always O2. I2 becoming I minus. Again, I2 becomes I minus, it's reduction reaction. Who reduces this? H2O2 reduces I2 to I minus. Which medium? Basic medium. Bahut badhiya, nice. Byproduct in acidic basic both medium, when H2O2 behave as reducing agent, byproduct is O2. So bhaiya, here the byproduct can be H2O or OH minus. In acidic medium H2O, in basic medium OH minus. Here the byproduct is always O2, whether acidic or basic medium. Now, how to store H2O2? Understand here, H2O2 in the presence of sunlight decomposes to give H2O plus half O2. It decomposes happily. Also, in the presence of finely divided metals or even metals and alkali or base, we can say, this reaction becomes very fast. This decomposition becomes very fast. So, bhaiya, storing H2O2 is very, very crucial, very, very tough. Understand what we do? We store in the wax-lined glass or plastic. Why not metal? Because metal will catalyze the decomposition. Also, it should be stored in the dark. Why so? Because bhaiya, in the dark, sunlight will not be there and bhaiya, it will be saved from decomposition for some time at least. What is the stabilizer added there? Urea. So, bhaiya, clear-cut MCQ statement type question you can get from here. So this is about the H2O2. Next, reaction of D2O. I will just tell one thing about the reaction of D2O, which is a very simple conceptual idea. I don't think anything further will be required to you to understand. For example, if you know the reaction, let us say SI, or we can say BCl3 is there with H2O, for example. So what happens here? OH comes, you get BOH whole thrice or H3BO3. In the same way, if I take D2O na, same reaction will happen, but instead of OH, you get OD whole thrice or D3BO3. Similarly, if I take CaC2 with water, I get C2H2, preparation of ethine. Similarly, if I take D2O, what will happen? Nothing, C2D2. So heavy water react like water only in all the cases. You don't have to remember the reaction of D2O separately. Just focus upon the reactions of water, which I already told you. Cut, copy, paste for D2O. Just replace the hydrogen with deuterium. That is all. Now I will be discussing about some numerical parts here now. Make sure this part, byproducts, are very important. So now I'll be discussing about the questions which are numerical part of this chapter of hydrogen. Numerical part from this chapter, frankly speaking, is not that much important. But because the questions are very commonly asked in the local test, you should be prepared for your own confidence. One thing only that can be asked in the NEET exam is the solved example in the NCERT where the volume strength is converted into gram per liter also. That you have to remember. One direct formula, one direct trick I will tell you. No need to follow the solved example as it is. Question is there in the NCERT, the whole solution you don't have to follow for the NEET examination. Just follow the direct trick that I will tell you. Now, starting now. Firstly, degree of hardness. What is degree of hardness? Degree of hardness is the weight of CaCO3 apparently present in the hard water. Sir, apparently present? Higher. In reality, CaCO3 is a precipitate. So, it's a hypothetical weight of CaCO3 present. So, hypothetical weight, how can we find? I'll tell you the trick as well. But weight of CaCO3 present by weight of water into 10 to the power 6 ppm. So this 10 to the power 6 is there, so the value will come in ppm. Again, both the mass should be in the same units, so prefer grams here. So देखो यार, the trick is very simple. The moles of M2 plus in the water. M2 plus means Ca2 plus or Mg2 plus. Sir, how will get that mole? Simple. If CaSO4 is given, MgSO4 is given, CaCl2 given, MgCl2 given, MgHCO3 whole twice given, CaHCO3 whole twice given, just find their moles. Whatever their moles are, it will be equal to the moles of the Ca2 plus and Mg2 plus ion, and that you have to take equal to the moles of CaCO3. Sir, what does this logic mean? This logic means nothing. This is just a way of finding the hypothetical amount of CaCO3 there. Actually, CaCO3 is not there. So, bhaiya, they will give you the M2 plus ion in the water, in the hard water. From there, you will find moles, and those moles you have to take equal to the CaCO3 moles, and that's your trick. What is the molar mass of CaCO3? I think many of you might be knowing it, but the molar mass of CaCO3 is 100 grams per mole. Very lucky number it is, easy for calculations as well. Chaliye, let's carry on. Now, first question, 1 kg hard water sample has 1.9 gram of MgCl2. Find its degree of hardness. Simple yaar. 1.9 gram MgCl2. So Mg2 plus moles I want to find, and that mole will be equal to CaCO3 moles. How to do that? Moles of MgCl2 will be given mass of MgCl2 by molar mass of MgCl2. Given mass of MgCl2 by molar mass of MgCl2. Given mass is 1.9, molar mass is 95. You got 0.02 moles. Happy? Now these many moles of MgCl2 contain these many moles of Mg2 plus is equal to the moles of CaCO3. So you understand that's a simple trick. Moles of MgCl2 equal to moles of CaCO3. It's not any logic there, just a simple trick to get the answer of degree of hardness. So bhaiya simple yaar. Moles of CaCO3 you got now, that was equal to moles of MgCl2. How much you got here? Nothing, your weight of CaCO3 will be moles into molar mass. Same formula, weight will be moles into molar mass. Molar mass will be shifted here. Now this time molar mass of CaCO3 is 100. So bhaiya 2 gram is the hypothetical weight of CaCO3 in the solution. So the degree of hardness is the weight of CaCO3 divided by weight of water. Sir, how you got weight of water? 1 kg means 1000 grams. Into 10 to the power 6, 2000 ppm you got. Sir, what if they give MgCl2, MgSO4, two different salts? No problem. Find the moles of MgCl2 by dividing his mass with his molar mass. Find the moles of MgSO4 by dividing weight of MgSO4 with the molar mass of MgSO4. You will get the moles. Add those moles. The total moles will be equal to the apparent moles of CaCO3, and from there multiply with 100. You will get the weight of CaCO3. Happy question, happy answer. One very nice question they ask conceptually in local exams only कि भैया 100 ppm MgCl2, 100 ppm CaSO4 is there. Who has more hardness? To understand, this ppm was gram per million gram. So भैया this is 100 gram in 1 million gram of water sample, MgCl2. This is also 100 gram in 1 million gram of water, CaSO4 is there 100 gram. Who has more hardness? So who has more number of Ca2 plus Mg2 plus? Because previously I have already told you that Mg2 plus Ca2 plus are the main villain for the hardness of water. So understand here, molar mass of MgCl2 is 95 gram per mole, CaSO4 molar mass 136 gram per mole. So very simple here, both of them are 100 gram in 1 million sample. Divide with the molar mass. So whose moles will be more? So sir, his molar mass is less. And bhaiya, moles is given mass by molar mass. Given mass for both of them, you can take 100 grams in 1 million gram of the sample. Simple. So both are 100 gram divided with 95 divided with 136. So sir, 100 by 136 will be a smaller number. So these moles are lesser per million gram of water and these moles are more per million gram of water. So the hardness will be more for MgCl2. As simple as that. What is volume strength? So dekho yaar, for solving the question of volume strength, use this trick. Sir, what is this trick? The trick is very simple. 1 liter H2O2 sample release dash liter of O2 at STP. Mug it up by heart. Say it 10-20 times, write in the notebook, this you have to mug up by heart because this is exactly what the definition of volume strength of H2O2 looks like. Understand, volume strength is a concentration term, just like any other concentration term like molarity, normality, but exclusively used for H2O2 only. That means you can convert volume strength into other concentration terms also. Anyway, तो देखो यार, volume strength 1 liter H2O2 sample release dash liter of O2 at STP dash liter, that dash is equals to the volume strength given. Understand? 10V means what? 10V means 1 liter H2O2 sample release 10 liter of O2 at STP. Sir, but our teachers have told us ml. That is also okay. 1 liter release V liter, 1 ml release V ml. As simple as that. Now, 10V means 1 liter H2O2 sample release 10 liter of O2 at STP. That is a statement type of question. Sir, how can this statement type of question be useful for us? Directly they can ask you, ki bhaiya, there is a 10V sample, then find how much O2 at STP will be released. How much O2 at STP will be released when 100 ml of that sample is taken. Simple. Sir, 1 liter is releasing 10 liter. That is 1000 ml, release 10 liter. So sir, 100 ml will release 1 liter of O2 as STP. You want to convert into moles? You can divide it by 22.4 liters. Volume of a gas at STP by 22.4 liter is moles. You can divide by the 22.4 liter and get the moles of O2 released as well. Direct question. What is important? This is the formula that you can keep in mind. That's the direct trick by which you can get molarity, normality, gram per liter and percent weight by volume. So all these formulas we have to remember. If you remember molarity formula, remaining are automatically clear. I'll tell you how. So dekho yaar, this question they can ask you for this 10V sample. It is a commercially available sample. I'll be finding molarity, normality, gram per liter, percent weight by volume. This is the formula directly. So dekho yaar, molarity is equals to volume strength by 11.2. What is volume strength given as 10? Sir, V, I keep V aside. Volume strength is 10 divided by 11.2. So bhaiya, this is the molarity, clear cut. 0.89 molar comes here. Easy. Normality is 10 by 5.6. So you were saying normality formula we don't have to remember? Higher. Because you might be knowing it that normality is equals to molarity into valency factor. That's a very common thing. Hai na? And what is the valency factor of H2O2? Valency factor of H2O2 is 2. For H2O2, the valency factor is 2. So it's very simple. Ki bhaiya, normality is molarity into valency factor. So if the molarity is V by 11.2, normality will be V by 11.2 into 2. That is V by 5.6. So 10 by 5.6 came here. Then finding gram per liter. Sir, how can we remember this? You don't have to remember. Use your brain. You will very easily understand that molarity is moles per liter. And now I want gram per liter. Simple concept here. Liter same. I am just converting moles into gram. So sir, how to convert moles into gram? Every time same thing here. If you have moles, you want weight, multiply with the molar mass, you will get the weight, just like you got here. So bhaiya, multiply with the molar mass of H2O2, that is 34. 34 gram per mole is the molar mass of H2O2. So what we got? Mole per liter into 34 is gram per liter. So gram per liter is molarity into 34. As simple as that. So bhaiya, gram per liter will be how much? It is going to be 10 by 11.2 into 34 gram per liter. Sir, can we divide and get the answer also? Higher, now the division will be very easy. This will go approximately 3 times. So around 30 gram per liter is the concentration in gram per liter. As I said, volume strength is another concentration term. We are just converting them to the other concentration terms. In fact, you can solve mole analysis questions also. Volume strength questions can easily be converted into simple concentration based questions also. Sir, what about percent weight by volume? Simple. Molarity into 3.4. Molarity into 3.4 will be, that is 3% weight by volume is 3%. Percent weight by volume will be 3%. How, sir? Simple. M into 34 is 30. So M into 3.4 will be 3. As simple as that. Now, sir, how this formula came? That is also very simple here. Gram per liter was gram per 1000 ml. Hai na? This is gram per 1000 ml. Now, what is percent? Percent means per 100. So, this I want to get gram per 100 ml. This I want to convert into gram per 100 ml. So, how to do? Simple, yeah, this 0 has to be removed from here. For that, 1 decimal place I have shifted on the left. So, bhaiya, these conversions are all very easy to do, and usually they will stick to the NCERT part only while asking the question. So, the major thing that you have to keep in mind are major 2 formulas, molarity and gram per liter, because on this the solved example is given in the NCERT. Now, talking about questions, can they be tougher also? Yes, questions they can ask very tough questions also in the local test, but not in the NEET examination on these formulas. Now, what kind of tough questions they can ask? One oral question I can tell you. Listen carefully, you will understand very easily. For example, one reaction is given. That carbon is reacting with oxygen to form CO2. 12 gram carbon taken. 10V sample. Take na, chalo 10V kya? We take a divisible number. 11.2V sample taken of H2O2. From here, all the oxygen released from this sample is treated with 12 gram of carbon, and it get 100% converted into CO2. So understand the idea. So 12 gram of carbon taken. 12 gram of carbon taken means how many moles taken? 12 gram carbon means 1 mole taken. So sir, carbon plus O2 gives you CO2. So for 1 mole of carbon, we need 1 mole of one mole of O2 for reaction. And who is giving this O2? This bhai sahab is giving the O2. You have to find the volume of the H2O2 sample required. Simple. 11.2, what does it mean? It means that 1 liter of H2O2 sample release 11.2 liter of O2 at STP. 1 liter of H2O2 sample release 11.2 liter O2 at STP. That's a simple statement that we have remembered from here. So how many is this? How many are these moles? 1 liter of H2O2 sample release 11.2 liter means half mole. Sir, how? Divide with 22.4. I just told you. So half mole O2 at STP released by 1 liter, I need 1 mole, so bhaiya 2 liter H2O2 required. As simple as that. 1 liter released 11.2 liter. How, sir? 11.2 V was given. So I have written the statement like this. So bhaiya 1 liter released 11.2 liter. I got moles by dividing with 22.4 liters. Half moles came. With 12 gram carbon completely reacted means 1 mole is the stoichiometry. So with 1 mole of carbon, that is 12 gram, 1 mole O2 required. If half mole coming from 1 liter, so here 1 mole will be coming from 2 liters. Answer is simple, question is simple, but is not important that much for the NEET examination. Still, if you want to persist and do, because again, you don't have to take any risk at this point of time. So very easily you can keep this in mind as well. You can try as many questions also. But this is the end of the revision for the hydrogen chapter. Hydrogen as a fuel is a topic that you can read from the NCERT also. What is important there? Just keep in mind the tanks, the alloys we use for making the tanks. So those alloys are very important. Apart from that, hydrogen as a fuel, some calorific values are given. Not much important. Why? Because as per the MCI syllabus, it is not given in the NEET syllabus. But don't take any chance, but make sure one reading of that you can do. Whatever you are able to recall, more than enough. That's all from my side. This is Saurabh Pant signing off. All the very best for your NEET examination and hope you are safe at your home. So stay home, stay safe. Thank you.